In this video, let us see about Newtonian and non-Newtonian fluids. What are Newtonian fluids? Newtonian fluids are those which obey Newton's law of viscosity. Obey Newton's law of viscosity. And what are non-Newtonian fluids? Which do not obey Newton's law of viscosity are called non-Newtonian fluids. Let us see what are the different types of non-Newtonian fluids. If we draw a graph between the shear stress and velocity gradient du by dy, Newtonian fluid varies linearly. The shear stress varies linearly with velocity gradient, and this is Newtonian fluid. Newtonian fluids. And this is dilatant fluid. Dilatant fluids. This is pseudoplastic. So for this Newtonian, dilatant and pseudoplastic, there is no initial shear stress that should be applied. But for other non-Newtonian fluids, here it is Bingham plastic. And this is rheopectic fluid. This is thixotropic. And the one which lies on x-axis is ideal fluid, which means without even apply of the shear stress, the ideal fluid moves. And the line on y-axis, this indicates ideal solid. Even with apply of shear stress, it is not moving. So this is initial shear stress that should be applied to make the movement of the fluid. So these are divided into non-Newtonian fluids are divided like this. Non-Newtonian are divided into two groups. One is time dependent, one is time independent. Time dependent and time independent. With the time, the viscosity changes for time dependent. For time dependent, those are rheopectic and thixotropic. Rheopectic, thixotropic comes under time dependent, and time independent, dilatant, pseudo, and Bingham comes under time independent. So let us see one by one. We have seen that tau is equal to mu into du by dy. The generalized equation for this is tau is equal to tau y plus a into du by dy whole power n. Here a is called flow behavior index, and n is called flow consistency index. So for Newtonian fluids, this is the equation. So what will be the tau y? Tau y is equal to 0 and a is equal to 1 and n is equal to 1 for Newtonian fluids. What is for dilatant fluids? For dilatant, tau y is equal to 0 and n is greater than 1. So example of dilatant fluids is butter, sugar solution are examples of dilatant fluids. And also these dilatant fluids are called as shear thickening fluids. Shear thickening. What is meant by shear thickening? Shear thickening means as the applied shear stress increases, viscosity also increases. That is the meaning of shear thickening. And next is pseudoplastic. Pseudoplastic. For pseudoplastic, tau y is equal to 0 because it starts at origin and n is less than 1. And examples of pseudoplastics are blood, milk, paints are the examples of pseudoplastics. These pseudoplastics are also called as shear thinning fluids. Shear thinning. What is meant by shear thinning? As the applied shear stress increases, viscosity decreases. That is the meaning of pseudoplastic. And the next is Bingham. Bingham plastic. In Bingham plastic, tau y is not equal to 0. Some initial stress should be applied for the movement of fluid. Tau y is not equal to 0, but n is equal to 1 because it varies linearly. N is equal to 1. And what are the examples of Bingham plastic? Example: sewage sludge. Sewage sludge is an example, and the toothpaste is another example. For this, initial shear stress should be applied so that toothpaste comes out. And the next is rheopectic. These are time dependent. Rheopectic is time dependent. So in rheopectic, tau y is not equal to 0 because initial shear stress should be applied for movement and n is greater than 1. So rheopectic fluids are those as time increases, viscosity also increases. As time increases, viscosity increases. Examples are gypsum, printer ink. And in last is thixotropic. In thixotropic, here tau y is not equal to 0 and n is less than 1. Here, as time increases, viscosity decreases. And the example of thixotropic fluids are lipstick. As time increases, this lipstick will be more liquid. And ice cream are the examples of thixotropic. So these are the Newtonian and non-Newtonian fluids.